the fourth session. The topic of the fourth session is research writing tools and techniques. The research person for this particular topic is Dr. Sujit Jayaprakash. Presently, he works as a director and business head at New Edge Infotech, Ghana. He is holding following educational honors. His PhD in computer science. He has over a decade of experience in education sectors in India, Africa, and Latin America. I welcome you, sir, for this webinar to give your valuable inputs to the participants on behalf of Computer Science and Information Science University, Karnataka. Please, you can continue your session.
Thank you, ma'am. Good morning to everyone. And before I would like to start the session, I request everyone to mute your mic. I'm sure by default it's already mute. I also would like to switch off my video so that I can start with my slides. I'm sure everybody can see my screen. Okay. So once again, good morning to everyone. And my name is Sujit Jayaprakash, and today's webinar topic is on research tools and techniques. First of all, I would like to thank the management of Srinivas University and as well as Dr. Jayantila for organizing such a wonderful webinar. It's a webinar series basically, right? So research trends in computer and information systems. It's quite a relevant topic, and I guess everybody will get benefit out of these webinars. So you all know that the times are not normal. I'm sure we'll be able to bounce back after this COVID pandemic with full vim and vigor. I pray to the Almighty for everybody's well-being. As Dr. Jayantala rightly introduced me, I'm currently working as the director and the business head of New Edge Infotech Ghana Limited. So I'm a business development professional with a strong background in IT training and administration. I have more than a decade of experience in the education sectors in India, Africa, and Latin America, with significant experience in senior management roles and leading institutional academic delivery improvement. I have completed my PhD in computer science and specialized in education data mining. My area of expertise includes data science, web mining, education data mining, and social media marketing. So today, basically, we are going to see some of the research tools and techniques in computer science. For many of you, I saw many of the PhD holders there, many of the professors out there. For them, this topic might not be relevant because this is basically focused on somebody who would like to start their research work or who would like to streamline the process of research. So the contents of these slides would be very basic and rudimentary. For example, I would like to start with the defined research and the role of research and some of the tools which could help you in while doing a research in computer science. So let's start with the defined research. We all know the noun for research. So it's basically the systematic investigation into study of materials and sources in order to establish facts and research new conclusions. So if I elaborate this a bit, research is basically a systematic study on different resources to do some findings and establish facts. But then if I take you back from where this term research came from, so the word research is derived from the Middle French called rechercher, so which means to go about seeking or searching for information. So the term itself being derived from the Old French term called rechercheur, a compound word which combines re plus chercheur or a searcher, meaning search. So it is actually established, or earliest recorded use of the term was in 1577. So you can imagine for how long this word has been in use. So for example, everything you do today is a research. Everything you try to find out, every fact you would like to establish, you call it as a research. Although somebody might have already done that, but you would contribute from your part, maybe with a better solution. So that's what research is all about. And role of research. So these days, because of our academic qualification or academic ranking, everybody wants to secure an MPhil, everybody wants to complete their PhD, everybody wants to go for the post PhD. So the ultimate thing is you have to do some research and you have to um, establish the facts, and then you have to publish your papers, publish your thesis. So this is what everybody is looking for. Because of that, some of them, what they does is that they don't do a proper research, or they don't do a proper research processes, and end up producing some data which are not fact. Um, However, they pass through this and then get their qualifications, right? But there are so many people out there who do real research works. For example, many of the professors out here, I was going through their Google Scholar list and stuff. I saw they have done some comprehensive research in their field, and they have done some interns works, and they have established so many different facts. So um, we have people like that amidst of us. So a role of research is that the researcher should be able about some problem that encourages enthusiasm and interest for others. You cannot take out a research topic just because your guide has advised you to take. For example, if somebody would have advised me I should go for digital image processing, I wouldn't go for it because I don't know what it is. It's not about I don't know what it is. It's like I can't get my data. I don't have hands-on experience with that. So if I tell you my experience, my research was on education data mining, basically on predicting student academic progression. The reason why I chose this topic was I was working as a registrar of a university, and then I used to deal with a lot of student data, a lot of student graduate student performances and stuff. So when I had to choose my topic, I thought that would be, that's the topic was quite interesting for me, predicting academic progression. If I can predict a student's progression after his 2 semesters using this historical data, it it's kind of it interested me a lot. So I thought that would be my topic, and I picked on it. It helped me a lot because, as I told you, the research should be about some problem that encourages enthusiasm. If it is not going to encourage you, if it is not going to entice you, if it is not going to push you to go forward, then I don't think you should pick that as your research topic. And also, there should be some interest for the people who are listening it. It should contribute to the society. It should contribute to the research field you are in. So you have to ensure both these things. It should go simultaneously. And it is often generated from the thought what we have got now from past is not quite right or good enough. We can do better. If you pick up a research topic, if you analyze that if you go through the work of various researchers, what they have done, what they have not done, you might find something missing out there. You might find some gap. You might find some loophole out there. So that's where you step in as a researcher, and that's what your first step is all about. If you're able to find the gap, if you're able to find the loophole in that, then you are going to provide a solution to that. That's where, as a researcher, you are going to take your first step. So it consists of work that leads to meaningful contribution and evaluates that contribution. Of course, so once you pick your topic for your research, once you start analyzing various contribution of different researchers, and then the next thing is you will find a gap in it. You're going to provide a solution, which is going to be a meaningful contribution, and that also evaluates the then the other researchers around there, they're going to evaluate your contribution. So your research generates in some way a better solution to the problem. It advances the state of art. So that's another fair point which we have to see here. And it needs to be and used to have an impact. Of course, as I told you, you cannot just pick up a research topic which does not have any impact on the society or any impact on the field of academia. So your topic should definitely make some impact in the society. It should contribute to the welfare of the people out there. So pick a topic which resonates all these points, what I told you. It probably needs to be reviewed before most will consider using it. Of course, so when you put out your research topic, when you put out your solution for a problem, definitely people are just not going to hop on it and start using it. It will take its own time. People review it over and over. Researchers will review it and they will see the pitfalls in that. They'll see the advantages of it, and finally, people will start using it. So you should keep this in mind. It will be reviewed before most will consider using it. So who does the research, right? Um, Mostly we have seen that all the research uh, papers, you will see two authors, basically a guide, your guide, and basically yourself, who is writing the research. But if you see the research papers, um, which are highly noticed in Google Scholar or any other field, is those research papers which are written in a team. Individually, you can make contribution. I'm not saying you cannot make the contribution. Individually, definitely you can make a contribution, but then, yeah. So individually you can make a contribution, uh, but as a matter of fact, sorry, yeah. As a matter of fact, when people are not there to give you feedback, when you don't involve multiple skill set, then the authenticity of what you're trying to say um, might be questionable. I'm not saying people are not having skills to establish facts, but then if you're adding uh, if you're making a team to work on your research, definitely it has its own added advantages. So the team almost always makes the process easier, as we all know. So once you get feedback from different team members, it helps you in publishing your research works. Multiple skill set and division of labor, this is another important thing. You might be good in data collection, data analysis. The other person might be good in mathematical models. The third person might be good in how to um, do a technical writing. So if you are ready to divide your labor work, if you are ready to uh, work as a team together, then the paper which you are going to publish out there would be a superb one, right? So each member can work to their own strengths. So these are some of the things you have to take in mind when you get involved yourself in the research work. So I've been explaining topics for a while now, so I just wanted to go for this exercise. Um, I think there is a chat box. I would like to know, read this question. So what is a research? So I have given few points. A combination of investigation of past work and effort in the present that will help others in future. A set of opposites, fun and frustration, small steps and large insights, building on others' work and contributing your own work, finding or developing something new that impacts the world, all of the above. Uh, so this chat box is here, so I can see some of them have already started giving the uh, answers. A, D, A. Okay, okay. I'll give you another 5 seconds more. Okay, that's fine. That's fine. Thank you. So it is. So those who have answered D, pat yourself on your shoulders. You have done a good job. So the answer is D, all of the above. So a research is a combination of investigation of past work, historical work, right? You investigate on it, and effort in the present. So you come up with your present work that will help others in the future. It's a very simple definition, right? And it is definitely a set of opposites. You have fun and frustration in this. You'll have fun once you do research on a topic. When you start finding out new things, it also frustrates, right? So you have to read a whole lot of paper before you come up with one research topics. Small steps and large insights. So you might read some 50 papers, but then the kind of insight what you're going to put out there, it's pretty large. It's going to help a whole lot of people out there. Building on others' work and contributing your own work, right? It's a set of opposite, right? So building on others' work, you're going to work on others' um, information, and you're contributing your own work. So it's right. The C is finding or developing something new that impacts the world. So the answer is A, B, C. So it's all of the above. Thank you for your quick answers. Let's go for the next exercise. It seems to be fun because a lot of people are contributing here. This is the next one. What is not a research? Playing with the technology, book reports, programming project, commercial product development, doing what others have already done. So which one is not a research? So answers are coming in: B and E, A, E, E, E. I'll give you another option. Maybe one or two people can unmute your mic and give me the answer for this. It's a one or two people can unmute and give an answer for this, if the admin is allowing us to do that. Is somebody is talking? No. Okay. Okay. I think time is up. Sincere apologies to everyone. Sorry. I intentionally, yeah, some Govindraj Chittapur raised hand. Yeah, Mr. Govindraj. Let me see if I can unmute you here. Yeah.
Hello, sir. So myself,
Yes.
Govindraj from Basaveshwara College.
Okay.
So that research is that what is not a research is your question.
Yeah.
So usually doing what others have already done is actually it's not a research.
Okay.
But in literature survey we are referring it as an context.
Yeah.
But we could not repeat it as a research. We need to say. Suppose someone will identify some method. If we'll do it, it is claiming it as it's not a research at all.
Okay. Okay. Got it, sir.
That's my view.
Got it, sir. Thank you. Thank you. So I'm unmuting you again. Thanks a lot, Mr. Govindraj. It's a very good answer. But again, sorry guys, you have to. I mean, sincere apologies because I have intentionally hidden the option F, which is like all of the above. So you're playing with the technology is not a research at all. If you tell me that you opened your Veka and then you have uploaded some data sets and then you have tried to find um, you have run an algorithm on it, and if you say that okay, you got an accuracy for your algorithm, that's not at all a research. Book reports, definitely not. If you write a programming project at the end of the semester, that's not a research. That's a documentation. Okay, so I have to pick one more. I think there is someone raised their hand. Let me just see. Is it okay? I don't know who it is. Okay. Sorry. Yeah, let me go ahead. So programming project at the end of the semester, if you think that you have done some programming and then if you are writing a thesis or something about it, that's not considered to be a research because um, it's a project. At the end of the day, it's a documentation. You're trying to tell somebody that how they can use your software. That cannot be a research, right? Commercial product development, definitely not a research. E, as Mr. Govindraj or Dr. Govindraj rightly said, doing what others have already done is not a research. Doing what others have already done, you go through it and then establish your facts, come up with a new finding. That's what a research is. So, guys, as a matter of fact, all these from A to E are not considered as research. Thank you for joining this exercise, and let's move on to the next topic. The scope of the research. So the scope of the research differs from academic. I mean, I've just tried to differentiate between qualifications: undergraduate work, postgraduate work, PhD work. Undergraduate work is basically you are trying to learn the process and get started down the path, right? Whereas postgraduate process, you contribute the contribution expected at the national to the world. For example, if you might do some research work, but it must be considered nationwide, may not be in the international sector. But when you progress towards PhD, that's where the real thing comes in. Your contribution expected at the global or world level, whatever you're going to put out there, whatever findings you're going to establish out there, that's going to be in the global work, that's going to be considered as a global one. So the background investigation on all your work make meaningful addition to the world knowledge. Everything involves in your PhD work. So your contribution is expected at the global level. Now, when I talk about traditional research methods, basically the traditional research methods are of three types: exploratory research, constructive research, empirical research. That's what it is classified as. So when you say exploratory research, it is to identify and define a problem or a question. There is some problem, you're trying to identify it, you're trying to um, uh, research about it, or you're trying to write about it. That's called an exploratory research. The second one is the constructive research, so which basically tests the theories and propose a solution to a problem or a question. So you go through a whole lot of theories and then try to propose a solution from the theories what you have learned to a problem or a question, right? So that's a constructive research. And the third one, most of us are involved, most of the computer science professionals are involved, is the empirical research, where which tests the feasibility of a solution using empirical evidence, which is the research evidences. Some established facts are already there. You go through it, you investigate on it, and then you come out with your own fact finding. That's called empirical research. This empirical research is divided into two major types. One is called qualitative research, another one is quantitative research, and also the third one called mixed research. We'll see this in detail. So basically, the qualitative research, the researchers choose qualitative or quantitative method according to the nature of the research topic they want to investigate. You cannot say that for all the research you have to apply qualitative, for all the research you have to apply quantitative. No, not like that. It depends on the topic you choose. Okay, so Mr. Rajendra has asked for a PPT, for the PPT. Definitely, I'll share with you the PPT. So, sorry. Okay, let's continue with this. Now, a qualitative research involves understanding human behavior and the reason that governs such behavior. So by asking a broad question, collecting data in the forms of words, images, videos, etc., and you'll analyze that and search for the themes. So this type of research aims to investigate a question without attempt to quantifiably measure variables or look to potential relationship between variables. For example, let's say let's take the example of Srinivas University, right? And they must be having a canteen inside the university. If the college management would like to know the how the canteen is, or if they want to know how the campus dining services, what is the expectation of the students, what do you think they'll do? Definitely, they'll randomly pick one or two students. They do an one-on-one interview. They will ask them, um, how do they find the mess, whether the food provided there are tasty enough. So, and then what they do is they'll also go for the focus groups, which is like they'll select a group of people and take feedback from them, assuming like nowadays it has become a multicultural environment, or uh, even foreigners are coming to India to do their programs. So a canteen is a common place where everybody comes and takes their food, right? So for example, if somebody comes from Bangladesh, if somebody comes from, so you take them as a focus group and you find out from them and how the service of the canteen is. And then you have an ethnographic research, you have process of observation, you have the record keeping. Also, you have case study research. Maybe they can take reference from other universities how they are doing it, or some case studies. So everything involves in the qualitative research. It is not a quantifiable one. You cannot go and say that, okay, I spoke to um, 15 people, 15. You cannot put out a survey form and then based on the survey form you cannot come out with your results. So qualitative research is basically uh, uh, what do you call a research that involves human behavior and the reasons that govern such behavior by asking a broad question, right? So the next one is quantitative research. So what a quantitative research means, it's basically a systematic investigation of phenomena by gathering quantifiable data and performing statistical, mathematical or computational techniques. Again, let me take you back to my research paper on predicting academic progression of students. If I have to predict a particular, if I have to predict the students' progression, how what they're going to score after their semester 3, what I need is I need their historical data, which is like quantities, right? I might take like 2,000 student records of their semester 1, semester 2, semester 3, plus I'll take their grades of 10th plus 2, or their socio-demographic details, their parents' details, what their income was, from where he is coming, average distance travel, whether he is in a hostel. So I take a whole lot of data which are quantifiable, maybe 5,000 records, and then I feed it in the system to train my model, and then I upload test data to see whether um, to analyze the accuracy and also to get the output of the students I want. So this is basically called a quantitative research. It's basically a systematic investigation of phenomena by gathering quantifiable data and performing statistical, mathematical, or computational techniques. I'm sure you must be you're clear about this. The next one is mixed research. So some of you might say that qualitative methods are the best. Others might say that quantitative methods are the best. But the research question drives everything. You cannot say that qualitative is best. You cannot say that quantitative is best. In some cases, you might have to go for the qualitative. For example, I told you this predicting student academic progression. It can be considered as a quantitative research, but in some cases, it can be considered as a mixed research. For example, if I want to understand how a group of people use internet at their home, how they use social media, I might need to take one or two interviews. I might have to record their answers, and I have to add it to my research. So it's called mixed research, right? So for example, if I divide this, qualitative research are basically focusing on constructivism, inductive logic, exploratory research, whereas quantitative is post-positivism, deductive logic, confirmatory research. And mixed methods are pragmatism, which is practical, abductive logic, qual and quant analysis. So these are the three different types of research. What we are going to see now is computer science research methodology. So a computing science researchers use several methodologies, as you all know, to tackle a question within the discipline. So the discussion starts by listing several of these methodologies. So in the future slides, I'm going to show you different methodologies we use in computer science. The idea is not to classify researchers or projects in each of these methodologies or to be exhaustive. So I'm just going to give you an overall idea of or labeling different researches happening in the computing field, right? So let's go for this. There are 6 methodologies. One is, formal, experimental, build, process, and model. I'll give you a quick explanation of all these things. Formal in computing science is a formal methodologies are mostly used to prove facts about algorithms and systems. So assuming like if you want to talk about naive Bayes algorithm, if you want to talk about decision tree algorithms, so it's mostly used to prove facts about algorithms and systems. So researchers may be interested on the formal specification of a software component in order to allow the automatic verification of an implementation of the component. So here what happens is the correctness or the quality of the solution generated by the algorithm is always analyzed. That's a formal research. The next one is experimental methodology. It is broadly used in computer science to evaluate new solutions for problems. So experimental evaluation is often divided into two phases. One is the exploratory phase. The researcher is taking measurement that will help identify what are the questions that should be asked about the system under evaluation. Then an evaluation phase, evaluating those questions what he has already taken. So the third one is a build research methodology. It is basically consisting of artifacts. So it's to demo. It is to be considered research. The construction of artifacts must be new, or it must be it must include new features that have not been demonstrated before. Right. The fourth one is the process methodology. This is to understand the process used to accomplish tasks in computing science. If you're building up something, let's say software engineering process, if you're trying to do a research on that, processes in a software engineering concepts, so that's called as a process methodology research. Then the last one is the model. So the model is something like, for example, whenever you build something, let's say a software or or a device, ideally you have to come up with a model for that. So the model should be a unique one. You will research multiple products in the market, and then you will come up with a blueprint of your own product, which will be better than any other product in the market, and you will do a model of it before you actually build the final product. So the model is somewhat like your final product, but you might not spend a whole lot of money in building a model, right? So the model methodology is centered on defining an abstract model for a real system. So it's not actually a real system, it's just a sample, you can say, right? Now, the model will be much less complex than the system that it models, and therefore will allow the researcher to better understand the system and to use the model to perform experiments. So these are the different methodologies in computing science field. Not only in computing science field, if you talk about engineering also, it involves all these models. Now, let's get into the tools which are used by researchers across the globe, and which helps them in doing research works. So if you talk about references or index resources, these are some of the things which you can hop on. Like for example, if you want to, I mean, many of you know that we all use Google Scholar to search for research papers. Even I do, everybody does that. There is ResearchGate, there is academia, there is a machine learning repository, UCI, there is Kaggle, there is GitHub, there is Web of Science, Springer, and many more sites are there, which helps you to look for research papers. For example, there are other research tools which are for non-computing field, BioWebSpin, Innocentive, LifeScience.net, MyScienceWork, a number of resources out there. But we in the computing field mainly focus on the Google Scholar, right? Before getting into Google Scholar, I also want you to take a look at this particular logo. I don't know how many of you have used this before. This is called SkyHub. What happens is, whenever you want to write your first research paper, people will say that download few IEEE papers and go through it and come up with your own paper. That's what they give you as an advice. But then many of you might not be having an IEEE account. In that case, what you have to do is you have to be dependent on your friend or a relative who works in a university which has an IEEE account, and then you ask them to download papers for you and share it with you. This is generally happen. This is what happens, and this is what happened in my life too. So one thing which helped me out is the SkyHub. For example, let me give you an example of this. So I'm going to open a Google Scholar. So let's say education, data mining. I need an IEEE paper. So let's say this Romero and Vensha. They are well known in terms of data mining as well as in education data mining per se. So when you click on this, I can't download this because you have to be an institutional subscriber. Um, okay, so you need to be an subscriber. So what I'm going to do is I'm going to use SkyHub. Um, so SkyHub is a website that provides free access to millions of research papers and books without regard to copyright bypassing the publishers. So it's kind of proxy, you can say. You are not going to spend money on this. So just click on it. I'm going to show you. What I'm going to do is copy this link, paste it here, open. Here you go, 18 pages, just like that. So you have downloaded the entire research paper here, right? So, sorry guys. I'll definitely share this presentation at the end of the webinar, please. So this is how you can use SkyHub, right? Now, the next thing what we are going to see is how to use Google Scholar. As I told you, many of you must be using Google Scholar. It's not a new thing which I'm trying to tell you. But then there is a process. There are some steps which you can take, which will ideally help you to streamline the way you research. So here you go with this, how to use Google Scholar effectively. Um, the first thing what I would advise you is to go for an incognito mode. So go here, this is an incognito mode. The reason why I'm asking you to go for incognito mode is your web browser, it stores the information in the name of cookies, which we all know. Whatever sites you go through, whatever you read from different sites, everything is stored, and they know your search behavior. So what happens is when you use it in a normal web browser, there are chances that the results what they're going to put out there is going to be more biased. So to avoid those biased results, I advise you to go for an incognito mode. So here you go, incognito mode, Google Scholar. Okay, so here we go. And the next thing what you have to do is use advanced search options to search in specific fields or to limit results by year range. So normally when you want to start your first research paper, they say that you should download the research papers from the last 3 years, including the current year. So let's say 2017, 2018, 2019. So all these things you can do in the advanced search, right? So I'm going to return articles between 2017 to 2020, right? And then find all the articles with all the words. Let's say I'm going to use education data mining, right? And with the exact phrase, with at least one of the words, I can put anything. Then I just click on this. So here you go. It has listed out all the papers which has education data mining, right? Then now next thing is use double quotation marks to search for multiple words. So if you want to search for multiple words, you can use a double quotation. So here is an example, climate change or the impact change of the world. You can put it in the double quotation. That's how they look for the exact word to search from a paper. Next thing is use alternative terms or use or this pipe symbol. So the pipe symbol is like, for example, this is a pipe symbol. So if I want to list out papers with magging or boosting algorithms, so it will list out all the papers. For example, here you go. It's an online bagging and boosting algorithms. It brings out either bagging or boosting, right? So you can take it like this. Now there is another example. For example, heart myocardial infraction attack. So these are the different terms. So when you are going to search, it is going to list out all these. Find heart infraction, myocardial infraction, heart attack, myocardial attack. So everything will come as an extra result. Now the another thing is exclude specific terms. Assuming I want to do a search on ensemble learning, but when it comes to ensemble learning, I don't want the research papers which has bagging in it. So if I want to remove bagging from that, I can use ensemble hyphen bagging. So this hyphen is basically to exclude specific terms. Then the next one is all in title, which limit your search to terms appearing in the title only. So it picks up the whatever you have mentioned. If it is only in the title, so it just picks up those kind of those research papers. Finally, you come up with the file type of the PDF. So let's say um, name based algorithm file type PDF. Did you see here? All the files are PDF files. It doesn't take you to any link to other pages. For example, let me click here. Look at this. Your PDF has already opened. You don't need to go to a Springer page. So I mean, this has a disadvantage because it normally it normally pulls out files from academia.edu, researchgate.net. It doesn't go to IEEE or Springer because they don't allow you to just upload PDFs. Download PDFs, right? The next thing is limit your search to certain websites or domains. For example, naive Bayes algorithm. I want to find out all the papers of naive Bayes algorithm only from Springer, right? Yeah. So if you see the search results, so this is from Springer, this is from Springer, this is from Springer, this is from Springer, and all your research papers are only from Springer. So you can just use this tool, this particular search term to download papers only from a particular website. And the next thing is personalizing it. For example, let's say I'll show you how to personalize it. Let's go for my library. Let's say if I do research on multiple topics, let's say web mining, if I do research on deep learning, I can create labels. Let's say I have already created a label called EDM. Let's say manage labels, create a new label. So let's say deep learning, right? Now I'm going to search papers on deep learning. Maybe only from Springer.com. What did I do wrong? Sorry. Seems okay. Let me go for this. Oh, sorry. I'm searching in my library. That's what the problem is. Okay. So now what you could do is first thing, you can list out all the deep learning So I'm not sure what is the problem here, but then, okay, fine. So just to explain you some of the papers you have searched, you can select it. And if it is related to a particular topic, then you click on the labels and you add it to your label, right? So that's how, if you go to your deep learning, you will find that there are a whole lot of articles which you search are under this. So like this, you can customize it. You can change, you can personalize the Google Scholar as per you want. For example, if you look at EDM, you don't have any papers because I've not added it. But if you go to deep learning, there are some papers here. I've added it. So these are the ones. Another thing is you can create alerts. Let's say I'm searching on neural networks. Let's say if I search on neural networks, then if I want to create an alert, I just click on it. I can create an alert so that anybody publishes a paper on neural network, I automatically get it in my inbox and I can read it, right? So these are the some of the things you can do in Google Scholar, which can help you to do your research effectively. Let's come to this topic called research management tools. There are so many research management tools. Basically, helps you to cluster your research papers and do your research effectively. There are some tools like Mendeley, RefWorks, EndNote, MarginNote, ReadCube, PaperPile. I basically use Mendeley. So if I have to show you, so here you go. This is my Mendeley. Here I can create folders. I can upload. For example, for to write my thesis, I have uploaded a lot of research papers here on chapter wise. I can go through it and then I can take notes of it. I can highlight it so that I can make it for the future reference. So you can do all these things. And assuming if you are going to have a team and different authors, you can create groups, right? So with the groups, you can add authors to it. Everybody can contribute to your research. So like that, the same thing can, it's a web-based software. So everybody can share the research works, what you're doing, and they can contribute to that. So similarly, EndNote, reference work, everything does the same thing. So use any of these tools to help you in writing your research papers. The next thing is survey tools. We all know that how survey tool works. For example, if somebody is new to, I mean, everybody knows how Google Form is used. For example, let me take a small example. So you go for your apps and you'll find here your Google Forms. So you can go to your Google Forms, then you can create a blank. So you can put some survey questions, right? So there are tools to choose whether you want a name, collect the name, you just use this. If you want to do some scaling, you can choose linear scale so that people can choose between 1 to 5. So multiple options are there. Once you do your survey form, click on send. You will get the link here, which you can copy and share it to all, or you can send it through their email IDs. Like this, you can collect surveys. However, these days, there are some sites like SurveyMonkey, JotForm, Typeform. They all come with inbuilt survey forms or like some predefined survey forms. Although we have to spend some money, Google Form is entirely free. I would suggest you go for the Google Form. But then if you want to make your survey form look classy, if you want everybody to say wow to your survey form, then I would suggest go for Typeform, which has a whole lot of templates. For example, there is a survey template. You can go for any of this. Let's say customer onboarding feedback. I can use this. So click on preview. So thank you for using the product. Do you have minimum 5 minutes to tell us about your onboarding experience? Sure. I can rate the product, go for the next. Okay. Okay. So there is a pre-built survey form. If you want to edit it, just click on this start with the template and sign in and edit it. That's all. Similarly, jot form, cognito form, poll daddy, everything helps you to create surveys. The next thing for you is the web data collection tool. If somebody is interested in web mining, and if you want to do web scraping, if you want to collect information from your websites, from different websites, you can go for Octoparse, ParseHub, DocParser. These are different tools which helps you in collecting information from websites. I have installed Octoparse for, yeah, here you go. So let me give you a simple example of Octoparse. Okay, so let's say recently a friend of mine has created a blog for herself, and she has published different blogs. So let me see if I can fetch out data from that blog. She has just published 3 articles, so let's see. So it's called writingcookie.com. Okay, this is it. So at a glance, if I go through it, if I see the articles one after another, it's hard for me to fetch any information out of it. I'm going to use my Octoparse, which is for web scraping. It's going to download the data from this site. Okay, here you go. So she has written 3 papers, right? One is Art of Storytelling, 6 Modern CVs, Best Online Tools. These are the links, and you know the user who uploaded it, and the days and the time to read each of these blog, and how many views it has got, how many likes it has got. So from a website, it just easily pulls out data and shows it to you for your research work. Similarly, if you want to take out from AliExpress, if you want to take from Jumia, if you want to take from Flipkart or Amazon, let's say if you want to go for women accessories, and if you want to find out what are those women accessories listed out there, and if you want to upload it to another site, so web scraping helps you a lot. So these are some tools, web data collection tools used in today's research. The next thing is, if some of you are interested in data mining or deep learning or neural networks or machine learning, for example, I would recommend you to go for any of these sites, UCI machine learning repository, because one thing in research we always struggle is the data. We don't get enough data to do our research works. So these tools comes as a handy for you, whether it is UCI or Kaggle or Weather Underground or Quandle or 538. Everything is going to help you to download data sets. A typical example I can give you was, so let's say Kaggle. You see there's a data set here. So there are a whole lot of data sets you can work on. And you can even search for example, my field is student progression, right? So if I search for student, there are data on student performance in exams. I can click on that. I can download the data in a CSV format and I can start researching over this. You will also find relevant research works. For example, if you see here, somebody has already worked on this data set, student performance in exams, and he has posted his codings here. He has mentioned what algorithms he has used. Now you can counter it, you can use a different algorithm of yourself and you can come out with your research work. So there are different things, right? Other tools to help you in research is, everybody struggles, mostly people from India, I mean, most of us struggle in writing a research paper because grammatically we find a lot of challenges. You cannot put a sentence without any grammatical errors, some of us. So in that case, Grammarly, Ref and Write, all these can help you. These are all kind of easy tools which helps you in editing your grammars. For example, let's say Grammarly. Um, so you can add it to your Google Chrome or you can add it to your Word document. Anything you want to do, you can do it. And then you just copy and paste your content there. It helps you to find grammatical errors in that. Okay, so for example, I've done some works here. So an article which I try to write as, yeah. So it analyzes, it gives me the overall score, and it also tells me some of the punctuations, words, choices. So I can click on this. For example, we might use the, a preposition everywhere and anywhere. So to avoid those things, you can use Google Chrome. So it automatically removes. And the current, wherever you need a preposition, wherever you need an article, wherever you need um, full stop, comma, apostrophe, it helps you and do all these things, right? So similarly, ref and write can also do those things. There are some statistical tools, GraphPad, easy calculation. You can use this when I share this PPT to you. You can try any of these tools and see. I think we are running out of time. I'm just trying to finish it at the Mac at as early as possible. The next thing is plagiarism checker. So the plagiarism checker, as you all know, we have Turnitin, we have Urkun, we have so many plagiarism checkers out there. Some of them it, it will cost you, but there are free plagiarism checkers which you can take help of. I think Miss Hemalata wants to share. I mean, she has raised her hand. Yes, Miss Hemalata. Hello. Okay. Sorry. The next thing is, yeah. The next thing is flowchart on how to read my paper. So many of you might think that reading a research paper is an daunting task, or for some of you it is an easy task too. So those who want to step into research, those who want to write your research paper, um, you have to understand how to read a research paper. So first thing is you begin by reading the introduction, not the abstract. You just don't open any article on Google Scholar and you will read the abstract and you don't think that, okay, this is it, I've understood. No, it's not like that. You have to start from the introduction. You have to understand what the authors have tried to tell you. So the next thing you have to find is identify the big question. What actually they are trying to do? What solution they are trying to provide you? What is the big problem they are trying to address? That's what you have to find out. The next step is summarize a background in 5 sentences. Read the introduction and just pick out 5 different sentences which can help you to understand it further. The next thing is identify specific questions. In introduction they might be writing about very basic thing about, let's say for example, if our research paper is on data mining, predicting breast cancer on using data mining tools, every author will start with a basic introduction to data mining. That's not the thing what you have to take a note of. What you have to take a note of is the next step, which tool he has used, what he has tried to, I mean, what is the actual question he's trying to address. So those things you have to take note of. The next thing is identify the approach, what approach he has handled here, or he or she has handled. Then read the method section. That's where you're going to get the actual idea of about the research paper. Then you come to the result section. Try to analyze how the results has been produced and see if you are able to interpret it in your own way. Then the next thing is determine whether the result answers the specific question. So now you're going to connect the results plus the big question so that you can combine and see which it has been properly addressed or not. You have to read the conclusion discussion carefully. So conclusion is where it tells you whether this research paper is whether you can consider this research paper or not. Sometimes in some research papers you will find that the introduction is something different, abstract is entirely different, conclusion would be totally different. So you need to see if it all correlates to each other, right? So the next thing is go back to the beginning and read the abstract now, so that you will understand whether the author has tried to put everything in the abstract or not. So this is how you have to start reading a research paper. Now the next step is how to start your own research paper. Select a topic of your own interest. That's true. We all selected, assuming we have selected our topic. The next thing is you have an idea, you do a research, you write a paper. So what happens in most of the cases is that they'll be doing a research for 1 or 2 years because you don't have that confidence to take a pen and start writing it or start typing on your Word document, right? Most of them lack this confidence. So I would suggest you have an idea, do a research about it, start writing a paper as soon as possible. You will do hundreds and thousands of mistakes, but however, you will get a confidence of writing a paper. Then you do a research again based on the conclusions you have brought in, based on the findings you have made. So the first thing what I would suggest is not I per se, everyone in the research field, everyone in the academia, if you ask them how to start your research, they'll say that start with the survey paper. That's the most important thing. When you do a survey, you will try to understand, you will try to uh, understand that what other researchers have done in this field, what they have contributed to this field, how they have contributed. So you start with the survey paper. Next thing is find the recent researchers' problem and solutions in your topic. You cannot take an age-old topic or an age-old research paper. For example, 1989 research paper, you cannot take it and then say that, okay, I'm going to work on it or I'm going to find a solution which is better than this. There must be thousands and millions of people who have already worked on that particular topic and would have proposed different solutions for that. So you need to find recent researchers and you have to see the solutions what they have given. The next thing is building a model to address your problem. Once you have understood this is what you have to do, then finally sit on building a model. Use algorithms, use mathematical models, try to understand and bring out your final solution. Rework on the proposed model to better the solution. The first solution what you are giving might not be a correct one or might not be a relevant one. You have to work over and over on it. You cannot just put one paper out there and say that, okay, this is the best solution I have brought in and this is what the world is going to accept. It's not like that. Because research is an intense field. You can ask any of the professors out there, till date they have been doing research right from their young age, even at the age of 60, 70 they have been doing research because every day new informations, new findings are there, new uh, researchers are coming into the field, they propose new solutions. So you need to work, you need to rework on the topic, on the problem, try to find a new solution, rework on it over and over so that you can make it better. So with this, I would like to end my session. And if you have any queries regarding this webinar, please note down my email ID and the phone number. Feel free to send me emails and messages. So I would definitely work on all these. I mean, send you the responses on time. I saw some chats coming up. Thank you. Useful topic. Okay. Uh, Okay, first now please mail this PPT. I think most of you have asked me to share this PPT. Definitely, I'll share the PPT. I think the right platform would be through Dr. Jayantala. So I'll forward this to her and I'm sure she will be able to get this to you.
Okay.
Thank
Any
you.
audience have questions, please raise. You can unmute your audio and you can ask him because it is a common topic. Okay. Very much thanks to you, Sujita Prakash. And it's a very much professional presentation and more attractive and highly knowledgeable and interactive session. So we want you to associate once again full day session. Hello,
Yes,
can you
ma'am.
hear me? Thank you,
Yes.
lot.